All right, everybody in their places. You guys ready on acid?
Ready on acid.
Ready in the blender?
Ready in the blender.
Tenfold. Go ahead and swap me the acid.
Let's get it Fracsim. Hotel wake up call got me getting up.
Today we're just going to be going over how to measure using the oscilloscope on different type mag pickups. And to see what we got going on here is we just got the regular gator leads plugged in on this side and the measure leads plugged on the other side. So I'm just going to go ahead and turn on my meter. And for simulating today, I have a homemade little fan with some nails I've glued on there to simulate a flow meter. It doesn't produce a nice sine wave, but it does work for demonstrating the oscilloscope. And what I've got on there set up right now is a 2-pin mag pickup. See there, just 2 pins. I've got that hooked up through some Deutz pins to just the measure leads. So you can see that right now, just the measure leads are hooked up. So I'm going to go ahead and go to the oscilloscope mode here, which is 24. And of course, nothing's going on right now, just a little bit of noise on the background. And I'm going to turn on our fan here, or simulated flow meter. And the reason you'd be looking for this, working on fracturing equipment, might be a turbine flow meter if you're not too sure if it's actually spinning. If they say there's no rate and you're not sure if the flow meter has something in it that's plugged off, or you just want to look at see how healthy your magnetic pickup signal is, that's when you'd use the oscilloscope. So see now it's spinning, and this here is kind of, you don't really see much, and obviously it's because the timing is not set correctly. I'm going to go ahead and hit F1. See in the bottom here it says F1 is auto, so I'm going to hit F1. And it jumps out, thinks for a second, and then it's going to jump back in. And there you have the waveform, and you see it's not nice and sinusoidal. Normally you'd have a decent sine wave from a turbine flow meter. This here is kind of dirty just because of the shape of the nails, but it does show you what's going on there, just to give you an idea. And that's how you do it with a 2-pin. One more thing I'd like to go over with the measuring mag pickups is actually if you wanted to get a quantitative flow rate in barrels per minute or meters cubed per minute from a frequency you're measuring from a turbine, or even it doesn't even have to be a turbine. You would just have to have the standard pulse per gallon K factor. Or if you knew the K factor of whatever system you were trying to measure on, I guess it would work as well. But for this demonstration, I'm going to be using a 2-pin magnetic pickup. So basically what you would do is, instead of going to measure oscilloscope, you would go to measure and then frequency. And here you can see you got your hertz up there, and it's a 2-pin now, so it's AC. See the max and the min are about the same, plus minus. And the duty cycle is kind of all over the place, but that's simply because the fan and the nails aren't the best combination for demonstrating a flow meter, but it works. And at the bottom here you see a F10 K factor. So I'm going to hit shift and then the F10 here, and it's going to give us a bunch of options. So if we were measuring by chance, we were on location, you're complaining about flow rate in the blender died, and you just wanted to see if the flow meter was actually spinning, you would just spin in your own 2-pin, and you could hook up just your measure leads right into the mag pickup, a 2-pin mag pickup, and then you would hit number 3, 6-inch flow meter, and it stuffs in just a generic flow meter. And down here you can see it says 7.92, and that's just a generic pulse per gallon K factor. And then of course the reading, instead of it showing hertz, now shows the meters cubed per minute. And you can see it jump a little bit, and that's mostly just because the type of simulation here isn't that the way the nails, etc., aren't that stable, but it's sitting right around 5 cubes a minute. And you could use that just to compare it to the slurry flow meter if you had another means of comparing it to give you an idea of if it was working correctly. You can also actually go in there again, and you can hit what we see here, number 6, which is adjust, and this is where you can manually put in your K factor. So if you were working on an 8-inch or something else, something larger, you'd have a smaller K factor, 2.5 pulses per gallon, something like that. And then of course the smaller K factor, the reading would be a lot higher. So there you go. Now if you wanted to get a bit more advanced, we can talk about how you would test a 3-pin pickup. So we're going to go ahead and do that. So first I'm going to stop the fan, and I'm going to screw in a powered 3-pin pickup. You can see the meter now is picking up 60 Hertz just from power floating around here. There's our 3-pin pickup. And we can do a 3-pin pickup and power it and check it with a scope right from the Fracsim. So what we're going to do is on the squid leads, we're going to grab 24 volts because a 3-pin pickup, as you know, needs 24 volts. So I'm going to grab the lead here that says 24 volts. 24 volts. And I'm going to hook that up to pin A. And I'm going to hook up the ground pin to pin B. And measure lead to pin C. So we still have noise on there, you can see. We're going to jump out, and to get it to work, basically there's a new system on here, but I want to go about the old way of doing it. And the old way of doing it is you'd actually go into your settings, turn on your 24 volts, and then go back to your oscilloscope. Of course, get the fan spinning again. Too close there. See, we have nothing right now. And I don't need to even hit auto to see that there's nothing. It should be jammed at 24 volts. And the reason we don't have anything is because this type of magnetic pickup needs a pull-up resistor. So what you'd normally do is you'd hook up a pull-up resistor to this system. I've introduced something in the latest firmware. It's 3.0 and up. You can actually turn on an internal pull-up. So if you go into specials and just hit scope pull-up, it'll actually turn on the oscilloscope and do an internal pull-up on it. And since we're in auto, you see it automatically sized and everything went in position. We got a nice 24 volt waveform. With the magnetic pickup, you saw how, or the two-pin magnetic pickup, you saw how it just passed through 0. And with the 3-pin, obviously you shouldn't see any AC. It should be DC only, a pulse DC, and it should have a nice square wave and go from 0 to the whatever you're pulling it up to. Now in this situation, it's kind of jumping back and forth. That's just because, like I said, the nails on here aren't quite evenly spaced, so you get a different pulse as the different size nails pass around. And that's basically how you test a 3-pin to make sure everything's working correctly. Independently, of course. Of course, if you wanted to see the frequency, you press any other key on here other than left, right, up, and down. You can hit any other key, and it brings you up with a side menu. It shows you the frequency, the peak, the minimum peak, the duty cycle as well. And you see the duty cycle is drifting around, like I said, just because the different shape of the nails on there. And you also have the option to turn AC/DC off. So if I pressed 1, it's going to go to DC only, and then you see the wave goes right from the bottom to the top, because the range is now, instead of negative 28 to plus 28, it's now 0 to 28. Some other stuff you can do in here. You can take it, looks like you can take it off of auto, and it's done that automatically since I went into settings there. But you can actually, if you press the right arrow, you actually decrease the time base, and the left arrow increases the time base. And if you wanted to, up and down as well, it changes the voltage ranges. So we're already at 28, which is the max, but you could go down, which of course would or sorry, hit the up button, then you see it goes from 0 to 8 instead of 0 to 16, and now it's 0 to 4. It just keeps changing.